Hello and welcome back. We're in Chapter 10, Lesson 9, Probability of Compound Events. And we're just going to look at example 1. So we're using an organized list to find probability. So we're using an organized list. So we have to make a list to find probability. Okay, so here we go. A pizza parlor offers 7 different pizza toppings: pineapple, mushrooms, Canadian bacon, onions, pepperoni, beef, and sausage. So we have pineapple, mushrooms, Canadian bacon, onions, pepperoni, beef, and sausage. What is the probability that a random order for a 2-topping pizza includes pepperoni? So at the end of the day, we're finding the probability of a 2-topping pizza that includes pepperoni. Okay, there's a lot going on here. So, but first we have to make an organized list. So what we're going to do is we are just going to go ahead and start with the first item, which would be a pineapple. Now we need to define these variables. So let's go ahead and call, we'll call pineapple P, mushrooms M, Canadian bacon C, onions O, pepperoni, we'll call that one Pep, B for beef, and S for sausage, okay? So let's start with pineapple. What are the 2 toppings? We're gonna make a list, right? So pineapple could go with mushrooms, pineapple could go with Canadian bacon, pineapple could go with onions, and pineapple could go with pep. It could also, pineapple could go with beef, and finally pineapple could go with sausage. All right, so those are all the options for pineapple. Let's go ahead and go with mushrooms. So mushrooms could go with pineapple. Mushrooms could go with Canadian bacon. Mushrooms could go with onions. Mushrooms could go with pep. Mushrooms could go with beef. And also mushrooms could go with sausage. All right, so those are all the ones for mushrooms. Let's move on to Canadian bacon. So Canadian bacon could go with pineapple. I love Canadian bacon and pineapple. But moving on. Canadian bacon could go with mushrooms. Canadian bacon could go with onions. Canadian bacon could go with pep. Canadian bacon could go with beef. And Canadian bacon could go with sausage. All right, so those are all the options for Canadian bacon. Now let's go to onions. Onions could go with pineapple. Onions could go with mushrooms. Onions could go with Canadian bacon. Onions could go with pepperoni. Onions could go with beef. Onions could go with sausage. All right, let's do the next one. So what do? We did onions. So now we're on pepperoni. Okay, so pep could go with pineapple. Pep could go with mushrooms. Pep could go with Canadian bacon. Pep could go with onions. And pep could go with beef. And pep could go with sausage. All right, now let's move on to beef. Beef can go with pineapple. Beef can go with mushrooms. Beef can go with Canadian bacon. Beef can go with onions. Beef can go with pep. And beef can go with sausage. All right, and now we're on sausage. So sausage can go with pineapple. sausage can go with mushrooms, sausage can go with Canadian bacon, sausage can go with onions, sausage can go with pep, and sausage can go with beef. Okay, so what we need to do is go ahead and some of these, where if we have like pineapple and mushrooms or mushrooms and pineapple, they're the same thing. So we need to cancel out the duplicates. So, so pineapple, mushroom, mushroom, pineapple, those are the same. Pineapple and Canadian bacon, that is the same as Canadian bacon and pineapple. Pineapple and onions is the same thing as onions and pineapple. Pineapple and pep is the same thing as pep and pineapple. Pineapple and beef is the same thing as beef and pineapple. And pineapple and sausage is the same thing as sausage and pineapple. Okay, so we have all of these done here. All right, those are all done. That's better. Okay, now let's go on to the next one. Mushrooms and Canadian bacon is the same thing as Canadian bacon and mushrooms. Mushrooms and onions is the same thing as onions and mushrooms. So that's a duplicate. Mushrooms and pep is the same thing as pep and mushrooms. Mushrooms and beef is the same thing as beef and mushrooms. Mushrooms and sausage is the same thing as sausage and mushrooms. So now these ones are all done here. Okay. Now we're on to the next one. This is Canadian bacon and onions is the same thing as onions and Canadian bacon. Canadian bacon and pep is the same thing as pep and Canadian bacon. Canadian bacon and beef is the same thing as beef and Canadian bacon. And Canadian bacon and sausage is the same thing as sausage and Canadian bacon. So now these ones are all complete. And on to onions and pep is the same thing as pep and onions, so that's a duplicate. Onions and beef is the same thing as beef and onions. And onions and sausage is the same thing as sausage and onions. So now these ones are complete. So we're on to this one. Pep and beef is the same thing as beef and pep. And pep and sausage is the same thing as sausage and pep. So this is a duplicate. We need to cancel it. And then beef and sausage is the same thing as sausage and beef. Okay. So if we're trying to find the probability, what is the probability that a random order for 2-topping pizza includes pepperoni? So we're going to find the probability that for pepperoni. Okay. And that's going to be the favorable, right, over the total number of outcomes. So now we know that the total number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the total number of outcomes is 21. So that goes on the bottom. Now we just need to figure out, well, which ones are the favorable ones? The favorable ones are the ones that include pepperoni. So this one includes pepperoni, and it's nice because it's pep. So it stands out a little bit more. These include pepperoni. This includes pepperoni. And then we have these two also that include pepperoni. So there we have 1, 2, 3, 4, 5, 6 options that include pepperoni. So there's our probability, but we have to simplify this. So what goes into both 6 and 21? 3 does. 3 goes into 6 2 times, and 3 goes into 21 7 times. So that means that the probability that we'll get a pepperoni in our order is 2/7. So that is how you use an organized list to find the probability, okay? So now it is your turn, ladies and gentlemen, to check it out, okay? So a pizza parlor offers 7 different pizza toppings. A pizza parlor offers 7 different pizza toppings: pineapple, mushrooms, Canadian bacon, onions, pepperoni, beef, and sausage. What is the probability that a random order for a 2-topping pizza includes onions and sausage? So again, we have pineapple, mushrooms, Canadian bacon, onions, pepperoni, beef, and sausage. So we're going to go ahead and define our variables. This is going to be, let me use something that stands out here. Okay, pineapple is going to be P, mushrooms is going to be N, Canadian bacon is going to be C, onions is going to be O, pepperoni is going to be pep, beef is going to be B, and sausage is going to be sausage. So what you need to do is go ahead and make your list like we just did, and then go ahead and find the probability of a 2-topping pizza that includes onions and sausage. Oh, okay, onions and sausage. Okay, there you go. So go ahead and make your list on your own, and then find the probability of a 2-topping pizza that includes onions and sausage. So go ahead and pause your device, work the problem out. When you get done, press play, and we'll talk about it, and you'll see how you did. All right, see you in a bit. Okay, we are back. Let's go ahead and see how you did on your organized list. So let's go ahead and start with pineapple. So you could have pineapple and mushrooms, pineapple and Canadian bacon, pineapple and onions, pineapple and pep, pineapple and beef, and pineapple and sausage. All right? Then we're going to move on to mushrooms. So mushrooms, you could have pineapple, mushrooms, you could have Canadian bacon, mushrooms, you could have onions, mushrooms, you could have pep, mushrooms, you could have beef, mushrooms, you could have sausage. All right, now we're going to move on to Canadian bacon. Canadian bacon, you could have pineapple. Canadian bacon, you could have mushrooms. Canadian bacon, you could have onions. Canadian bacon, you could have pep. Canadian bacon, you could have beef. Canadian bacon, you could have sausage. Okay, now we're on to onions. Onions, you could have pineapple. Onions, you could have mushrooms. Onions, you could have Canadian bacon. Onions, you could have pep. Onions, you could have beef. And onions, you could have sausage. All right, now we're on to pep. So we'll say pep, you could have pineapple. Pep, you could have mushrooms. Pep, you could have Canadian bacon. Pep, you could have onions. Pep, you could have beef. And pep, you could have sausage. All right, so that's it for pep. And now we're on to beef. Okay, so beef, you could have pineapple. Beef, you could have mushrooms. Beef, you could have Canadian bacon. Beef, you could have onions. Beef, you could have pep. And beef, you could have sausage. And now we're on our last one, which is, we're going to use this color here. So we're sausage. So sausage, you could have pineapple. Sausage, you could have mushrooms. Sausage, you could have Canadian bacon. Sausage, you could have onions. Sausage, you could have pep. Sausage, you could have beef. All right, perfect. Now we have to get rid of the duplicates. So we have pineapple mushrooms. That's the same thing here as mushrooms and pineapple. Pineapple and, what's that called? Canadian bacon. The duplicate for that one's here. Oh, snap. That wasn't very good. I just did the wrong thing. Hold on. Let's try that again. Okay, so what was this? This was pineapple, This was pineapple and Canadian bacon. Okay, so the duplicate for pineapple and Canadian bacon would be Canadian bacon and pineapple. And so we need to cross out that duplicate. All right, now we're on to pineapple and onions, which is the same thing as onions and pineapple. Pineapple and pep, which is the same thing as pep and pineapple. Pineapple and beef, which is the same thing as beef and pineapple. Pineapple and sausage, which is the same thing as sausage and pineapple. Okay, so those are all done. Uh-oh, that's kind of runny. A little runny. Okay, then we're moving on to mushrooms and Canadian bacon, which is the same thing as Canadian bacon and mushrooms. Mushrooms and onions, which is the same thing as OM. Mushrooms and pep, which is the same thing as pep and mushrooms. Mushrooms and beef, which is the same thing as beef and mushrooms. Mushrooms and sausage, which is the same thing as sausage and mushrooms. So now all those are complete. I'm just highlighting so I know what I've done and what I haven't. Then we have Canadian bacon and onions and Canadian bacon. Canadian bacon and pep, which is the same thing as pep and Canadian bacon. Canadian bacon and beef, which is the same thing as beef and Canadian bacon. Canadian bacon and sausage, which is the same thing as sausage and Canadian bacon. So yeah, there you go, right there. Okay, then on to the next. Onions and pep, which is the same thing as pep and onions. Onions and beef, which is the same thing as beef and onions. And onions and sausage, which is the same thing as sausage and onions. So now these are complete. And we can move on to pep and beef, which is the same thing as beef and pep. And pep and sausage, which is the same thing as sausage and pep. Okay, so these ones are now done, complete. And then we're left with beef and sausage, which is the same thing as sausage and beef. Okay, so we are trying to find the probability of a 2-topping pizza that includes onions and sausage. So onions, oh man, onions and sausage. That's going to be the favorable over the total number of outcomes. Okay. So, we know the total number of outcomes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 outcomes. Now, which ones are favorable? Which of these have onions and sausage? So I see onions and sausage just right here. So it looks like there's only one option that has onions and sausage. So that's going to be our probability. So the probability of onions and sausage is equal to 1 over 21. So if you got that one right, great job. Perfect, perfect, perfect. Okay, let's go ahead and look at example 2. Okay, example 2 is using a tree diagram to find probability. So we have, so now we're going to be using a tree diagram. All right, we've done those before to find probability. All right, cool. So we have Jack, Kate, and Linda. So Jack, Kate, and Linda line up in random order in the cafeteria. What is the probability that Kate randomly lines up between Jack and Linda? So what we need is for Kate to be between Jack and Linda. We need to find the probability of that. We're finding the probability of Kate being between Jack and Linda. So to find the probability, we need to know the favorable and we need to know the total number of outcomes. So what we're going to do is we're going to use the tree diagram right now to find the total number of outcomes. So First, let's just take who's gonna, like a theoretical, who could line up first. Let's go with Jack. Let's say, hey, Jack, you're lining up first. Okay, so if Jack was to line up first, who would line up second? Well, really, there's two options, right? It can either be Kate or it can be Linda. Okay, and then who would line up third? If Jack is in first and Kate is in second, then that would mean that Linda would have to be in third. Or if it's Jack and Linda, Jack in first and Linda in second, that would mean Kate would have to be in third. So, this is third place. So one of these could be, I should have used, we'll call this Jack, J, K, and L. We'll say this option ends up being, I'll write it here, J, K, L, and this option, I'll use an arrow there, ends up being J, L, K. J, L, K. Okay? And let's just go ahead and highlight that answer there. So these are the end answers. Okay, so that's Jack being first, but somebody else could be first. How about we say that Kate is first? So I'm going to use a K. I'm just going to use the letters. And if Kate's in first, who could be in second? Well, Jack could be in second and Linda could be in second. But if Kate is in first and Jack is in second, then that would mean that Linda would have to be in third. I should have made that bigger. And if Kate is in first and Linda is in second over here, that would mean that Jack would have to be third, which means that we would have Kate, Jack, Linda as an option, and we'd also have Kate, Linda, Jack. Kate, Linda, Jack as another option. Okay, but we could have another person in first. We could have Linda in first. So we could have Linda, and if Linda's in first, who would have to be in second? Well, it could be Jack or it could be Kate. Now, if Linda's in first and Jack's in second, who would have to be in third? Well, it would have to be Kate. And if Linda was in first and Kate was in second, who would have to be in third? Well, it would have to be Jack. So that means we would end up with Linda, Jack, Kate, Linda, Jack, Kate, or we would have Linda, Kate, Jack. Linda, Kate, Jack. Okay? So now we're ready to figure out our probability. So our probability that Kate is in the middle, so we're doing the probability that Kate is in middle, is found by the favorable outcomes over the total outcomes, right? So we know the total number of outcomes because it's 1, 2, 3, 4, 5, 6. So it's going to be over 6. Now, how many of these are actually favorable? Okay, let's see here. Okay, so which one, probability that Kate randomly lines up between, so we need Kate in the middle. So right here, we have Kate in the middle. That's one favorable, okay? No, Kate's not in the middle there. Kate's not in the middle. Kate's not in the middle. Kate's not in the middle. Hey, Kate's in the middle. So that's 1, 2 favorable outcomes with Kate being in the middle. And then we just need to reduce this, right? So 2 and 6, the common factor between them would be 2. 2 goes into 2 one time. 2 goes into 6 3 times. So that means the probability that Kate is in middle is 1/3. And that's how you find the probability using a tree diagram. So now it is your turn to check it out. So we have Jack, Kate, and Linda, all right? So they're all lining up. We have Jack, Kate, and Linda. They're lining up, and we're going to call Jack, J, and Kate, K, and Linda, L, all right? All three of those line up in a random order in the cafeteria. What is the probability that Kate randomly lines up last? So we're finding now that the probability of Kate being last. Okay, so we still need to do a tree diagram. And then from that, we're going to find the favorable and the total number of outcomes, and then we can figure out the probability. So now it is time for you to pause, and I want you to go ahead and work out this problem. Use a tree diagram, okay, first, and then from the tree diagram, go ahead and find the probability. Okay, go ahead and pause. We'll see you in a bit. When you get done, press play, and we'll talk about the problem. Okay, we're back. Let's go ahead and set up our tree diagram. Okay, well, let's go ahead and start with Jack being first. So if Jack is first, that means in second, there's Kate or Linda. And if Jack is in first and Kate is in second, then Linda must be in third. Or if Jack is in first and Linda is in second, then Kate must be in third. So we really end up with two options here. We have Jack, Kate, Linda, and Jack, Linda, Kate. Jack, Linda, Kate. All right? Perfect. Those are our two options. Okay, and now we're on to the next person. So let's talk about Kate. If Kate is in first, who would be in second? Well, it'd have to be Jack and Linda. Well, if Kate is in first and Jack is in second, that means Linda would have to be in third, leaving us with Kate, Jack, Linda. And then if Kate is in first and Linda is in second, that would mean that Jack would have to be third, leaving us with Kate, Linda, Jack. Kate, Linda, Jack. So those are those two outcomes there. One. And then the last person that could be in first place would be Linda. So if Linda is in first, who would have to be in second? Well, it'd have to be Jack and it'd have to be Kate. So we could have Linda, Jack, and then Kate, or we could have Linda, Kate, and then Jack. And from those, we get two more outcomes. We have Linda, Jack, Kate, Linda, Jack, Kate, or we have Linda, Kate, Jack, Linda, Kate, Jack. So there we go. Now we need to determine the probability. So it would be the probability of Kate being last. Of Kate being last. So that's going to be the favorable of Kate being last over the total number of outcomes. So we know the total number of outcomes. 1, 2, 3, 4, 5, 6. There's 6. And then the favorable, well, is Kate, we need Kate to be last. Is Kate last in this scenario? No. Is Kate last here? Yes, she is. So this is a favorable one. What about this? Is Kate last? No. Is Kate last? No. Is Kate last? Yes. Kate's last here. So that's favorable. Is Kate last here? No. So there's two favorable outcomes where Kate is last. Okay, and then we just need to reduce this fraction. 2 goes into both 2 and 6. So 2 goes into 2 one time and 2 goes into 6 3 times. So that means that the probability of Kate being last is actually going to be 1/3. All right, if you got that one right, wonderful, wonderful, wonderful. Okay, let's look on to example 3, finding the probability of compound events. So Micah rolls 2 number cubes, okay? So we have 2 number cubes going, all right? We're rolling them. Oh, we're rolling them. Trying to get them both on. There we go. All right. So you're rolling 2 different number cubes. Micah rolls 2 number cubes. What is the probability that the sum of the 2 numbers will be less than 4? Okay, so the sum of these 2 numbers, 1 plus 3, that is 4. So that wouldn't be less than 4. But what about this? 4 plus 5 would be 9. That is not less than 4. 1 plus 5 would be 6, and that's not less than 4. But right now I'm just randomly doing it. If you do this problem, you have to do a systematic way of writing down all of the possibilities, right? So here we know that for each die there's 6 sides, so this would be 6 sides. And on the other die there's also 6 sides, right? So one of the options is for a 1 to go with a 1, or a 2 with a 1, or a 3 with a 1, a 4 with a 1, a 5 with a 1, and a 6 with a 1, okay? Or you could have a 1 with a 2 with a 2, a 3 with a 2, a 4 with a 2, a 5 with a 2, a 6 with a 2. Or you could have all of these options and these and these and these, right? There's a lot of options that can happen. So what we need to know is what is the probability that the sum of the 2 numbers will be less than 4? So what's nice about this is, okay, so we want to find the probability. So we're finding the probability that the sum will be less than 4. Okay? The nice thing about this is all of the outcomes are listed, all right? So we have 1, 2, 3, 4. Oh, yeah, I'm sorry. So the probability of the sum less than 4. So we need to find the favorable over the total number of outcomes, okay? So we can figure out the total number of outcomes, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. There's 36 outcomes. Now we just need to find which ones are favorable, which ones are less than 4. So if we look at it, we could go 1 plus 1. Well, that's less than 4. 1 plus 1 is 2. That's less than 4. For this next one, 2 plus 1 is 3. So that one is less than 4. That one works. 3 plus 1 is 4. So that is not less than 4. 4 plus 1 is 5. That's not less than 4. 5 plus 1 is 6. That's not less than 4. 6 plus 1 is 7. That's not less than 4. But 1 plus 2 is 3. That is less than 4. 2 plus 2 is 4, and that's not less than 4. 3 plus 2 is 5. That's not less than 4. 4 plus 2 is 6, which isn't less than 4. 5 plus 2 is 7, which isn't less than 4. 6 plus 2 is 8, which is not less than 4. 1 plus 3 is 4, which isn't less than 4. 2 plus 3 is 5, which isn't less than 4. 3 plus 3 is 6, which isn't less than 4. 4 plus 3 is 7, which isn't less than 4. 5 plus 3 is 8, which isn't less than 4. 6 plus 3 is 9, which isn't less than 4. 1 plus 4 is 5, which isn't less than 4. 2 plus 4 is 6, which isn't less than 4. 3 plus 4 is 7, which isn't less than 4. 4 plus 4 is 8, which isn't less than 4. 5 plus 4 is 9, which isn't less than 4. 6 plus 4 is 10, which isn't less than 4. 1 plus 5 is 6, which isn't less than 4. 2 plus 5 is 7, which isn't less than 4. 3 plus 5 is 8, which isn't less than 4. 4 plus 5 is 9, which isn't less than 4. 5 plus 5 is 10, which isn't less than 4. 6 plus 5 is 11, which isn't less than 4. 1 plus 6 is 7, which isn't less than 4. 2 plus 6 is 8, which isn't less than 4. 3 plus 6 is 9, which isn't less than 4. 4 plus 6 is 10, which isn't less than 4. 5 plus 6 is 11, which isn't less than 4. And 6 plus 6 is 12, which isn't less than 4. So there we go. We have all of the favorable outcomes right here. So 1 plus 1 is 2, 2 plus 1 is 3, 1 plus 2 is 3. All of those are less than 4. So there's 3 favorable outcomes, so we put 3 on top. And then we just need to reduce this. So what goes into both 3 and 36? Well, I know that 3 does. 3 goes into 3 1 time, and 3 goes into 36 12 times. So that means that the probability that the sum is going to be less than 4 is going to equal 1/12. So yeah, that's how you find the probability. Now it is your turn. Okay, so to check it out with example 3, so Micah rolls 2 number cubes again. What is the probability that the sum of the 2 numbers will be less than or equal to 4? Oh, very interesting. So now it is time for you to pause. Go ahead and figure out the probability. When you figure it out, then press play, and we'll talk about the answer. Okay, let's go. We are back. We're finding the probability. Okay, so the probability of the sum of 2 numbers will be less than or equal to 4. So probability of less than or equal to 4 is going to be the favorable over the total. Well, we can figure out the favorable outcomes over the total outcomes, total number of outcomes. We can find the total number of outcomes by just counting, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there's a total number of 36 outcomes. Now we have to determine which ones are favorable or not. So let's count them up. 1 plus 1 is 2, so that's favorable. 2 plus 1 is 3, which is favorable. 3 plus 1 is 4, and that's okay because it can be equal to 4. Now 4 plus 1, that's 5, and that's not going to be favorable. 5 plus 1 is 6, and that's not less than 4. 6 plus 1 is 7, and that's not less than 4. 1 plus 2 is 3, and that is less than 4. 2 plus 2 is 4, and that is equal to 4, so that's okay. 3 plus 2 is 5, so that's not less than 4 or equal to it. 4 plus 2 is 6, which is not favorable. 5 plus 2 is 7, which is not favorable. 6 plus 2 is 8, which is not favorable. 1 plus 3 is 4, and that is favorable because it's equal to 4. 2 plus 3 is 5, which isn't favorable. 3 plus 3 is 6, which isn't favorable. 4 plus 3 is 7, which isn't favorable. 5 plus 3 is 8, which isn't favorable. 6 plus 3 is 9, that's too big. 1 plus 4 is 5, that's too big. 2 plus 4 is 6, that's too big. 3 plus 4 is 7, that's too big. 4 plus 4 is 8, that's too big. 5 plus 4 is 9, that's too big. 6 plus 4 is 10, which is too big. 1 plus 5 is 6, which is too big. 2 plus 5 is 7. 2 plus 5 is 7, which is too big. 3 plus 5 is 8, which is too big. 4 plus 5 is 9, which is too big. 5 plus 5 is 10, which is too big. 6 plus 5 is 11, which is too big. 1 plus 6 is 7, too big. 2 plus 6 is 8, too big. 3 plus 6 is 9, too big. 4 plus 6 is 10, too big. 5 plus 6 is 11, too big. 6 plus 6 is 12, and that is too big. So how many favorable are there? Let's count them up. 1, 2, 3, 4, 5, 6. Perfect. Okay, now we just need to go ahead and reduce this fraction. 6 and 36, there's a common factor of 6. 6 goes into 6 one time. 6 goes into 36 6 times. That means the probability that it will be less than or equal to 4 is 1/6. All right? Okay, if you got that one right, you did a great job, and we will see you next time. Goodbye.